Hi, I'm Teja Paravastu, an application engineer here at Maxim Integrated. In this video, we are going to see the influence of inrush currents on DC-DC converters. We are going to utilize the soft start feature of MAX 17501, which is ultra small, high efficiency synchronous step down converter to reduce the inrush current peak limits and regulate them under limits. What are inrush currents? Inrush currents are the maximum instantaneous current spikes that exceeds the steady state value for short duration of time during the power on cycle of the switching converters. The capacitors in the switching converters serves multiple purposes. They regulate the input and output voltage, provide stable bias voltage at the power rails, and they form as backup power. Initially, the inrush current causes the current spike while charging the capacitors to their steady state values. The peak value of inrush currents depends upon the capacitance value and the rate of charge. The region above the steady state value during the starting period is the inrush current region, with the peak value dependent on the characteristics of voltage ramp up time, total capacitance, and input source impedance. Large capacitance value induces high current spikes due to large CdV/dt that can create electromagnetic interference with other circuits or trip a circuit breaker for overcurrent alert. If the current exceeds the maximum rating of the components like MOSFET or exceed the inductance saturation current, PCB trace, and other critical components, the system can enter undesired states and the components could be damaged. Portable devices and other battery powered equipments could see a voltage dip from the battery and experience output voltage overshoot during startup transients. Hence, it is required to regulate the inrush current under limits. The control and optimization of input inrush current is out of scope of this video. Maxim Integrated has other product families to address the issue. In this video, we are going to regulate the inrush currents to the output using the soft start functionality of MAX 17501. We increase the slope of inrush current into the circuit by increasing the time for which the output voltage ramps up to the steady state value. The peak value of inrush current is reduced based on dV/dt slope and the currents are regulated accordingly. The soft start capacitor at SS pin is used to regulate the inrush current by increasing the rise time of output voltage and the soft start time controlled to the capacitor at the soft start pin. Soft start capacitance value is calculated as shown. By increasing the value of the soft start capacitor, the soft start time is increased, which increases the rise time of the output voltage ramp to reach the steady state value. We demonstrate the proposed work using the MAX 17501 HT EV kit. MAX 17501 HT EV kit accepts input voltage from 4.5 to 60 volts and outputs 2.5 volts at 500 milliamps. The link to MAX 17501 HT EV kit can be seen on the screen. The capacitor at the soft start pin is replaced with different value and inrush current is captured using current probe and oscilloscope. Corresponding to 1000 picofarad soft start capacitor, the inrush current huge spike caused the controller to turn off the part for protection. Corresponding to 6800 picofarad soft start capacitor, the inrush current peak value is almost reduced and the controller will slowly turn on the output voltage to its steady state value determined by the soft start time. Thank you for watching the video. Stay tuned for more updates on Maxim Integrated website.